So our project is about underwater object detection and classification using hybrid classical quantum neural network. Uh, so so we're gonna explain about the classical quantum neural networks and its novel approach. And we have used the two different approaches like binary classification, multi-classification in transfer learning with the three different transfer learning methods in three different technique networks like ResNet 18, ResNet 50, and Inception 3. So other than this, it has a huge capability in oceanography and fish farming, etc. Like we could make more exploration over it. So we just try to use a novel approach of QCNN to make use of it to predict more efficient than a classical network.
So we have used a publicly available data set which is called a C-animal dataset from Kaggle, which consists of about 23 classes with approximately 13,555 images. So out of these 23 classes, we will be using two classes which are crab and starfish for our binary classification, and 7 classes which are crab, dolphin, fish, jellyfish, lobster, sea urchins, starfish for our multi-class classification. So moving on to our proposed methodology, as my teammate explained earlier, we'll be creating an hybrid classical quantum neural network which combines both the classical machine learning techniques with the quantum computing principles to improve the accuracy and efficiency of certain types of problems. So the basic idea about this model is that we'll be using a classical neural network for feature extraction and a quantum neural network for final classification. This will be the basic explanation about our project. So the various coming next, variational quantum circuit will be the key component of our project. So variational quantum circuit, which is known as parameterized quantum circuit, consists of a sequence of parameterized quantum gates applied to the initial state. So in this circuit, we will be mostly doing an encoding process which will convert the data into quantum state. So there are two main components of this circuit, which are embedding layer and variation layer. So in this embedding layer, the classical data will be encoded into the quantum state by using the quantum gates. And in the variational layer, it consists of a sequence of trainable parameterized gate, which will be used to train the model by multiplying or changing the angle of the features into three different axes. So followed by a measurement layer, we will be using an estimation layer, which will um, in which we will be calculating the estimated value of those images so that the features will be converted back from quantum to classical, so that we will be able to identify and classify the images and class. So just next, the trust quantum circuit, which is a capsulation of three different layers, which are classical layer and a quantum layer and another classical layer. So that basically a classical layer, quantum layer is being sandwiched between two classical layers. The first classical layer will be a pre-processing layer, which will be used as a feature extractor, followed by a variational quantum circuit, and finally we'll be using the measurement layer, which is a classical layer. Next.
This is the overall view of the project and gives an idea about the transfer learning part and the encoding part in the quantum cycles and how it is classified. Going through the evaluation process of the model, we got a result of accuracy over here with a different hyperparameters. And we got this is a graph to evaluate our process and get the insights of the project. You could see the different types of graph we got in the different types of, for the different types of model. Let's see about the conclusion we got. So for the conclusion, we can say that the generalization gap between the classical model and the classical quantum model's accuracy and loss graph was very comparatively less because of its capability to handle the robustness and the noise interference in the images. So we could say that a classical quantum model best adaptable model for a underwater images. So overall, with this, we could say that ResNet 50 has a significant more accuracy than other models. So which has a great adaptation with the quantum circuits. Other than this, quantum circuits have a great capability to work with in the future. It has the capability to overcome the classical model to get to use and handle the data sets of underwater images. So that's it about overview of our project. So we can see about the process of our implementation of project. So you could see a user interface. In this, you could add an image. I have added an example image in that, so easily a user can be used these images to classify, to check the images are classified or not. So it gives an overall view of what the object or a living organism that classifies and what wrong classification has been done within a percentage. So even if you clear that, you can use and upload other images from our devices. So you could see it classifies the fish. So this is an overview of our project. Thank you.